Welcome back. So in this video we will be working on project number 10, that is credit card fraud detection, and we will be using logistic regression. Just a quick guide. Logistic regression is a classification problem that is used to classify different entities. In this algorithm, what we do, we try to find out the probability of a instance and find out to whom to whom class it belongs. Now coming back to our dataset, this dataset we will be using and it is available on Kaggle. I will be pasting the link of this article in the description. Now as you can see, there are around 31 columns, each representing each has a name of v1, v2, v3 and so on. What is v here? So as you can see in this article, you can see these are the PCA. What are these? These are the PCA. What are PCA? PCAs are the values that are derived from the original value. So original value must be something else and they are converted to some different values. That is known as a PCA. Just by reducing their dimensions, they are created. And at the last, we have the target column, that is the class. 1 means it is a fraud transaction and 0 means it is not a fraud transaction. Now coming back to our project, first we will import all the libraries. We will import logistic regression from sklearn dot model selection train test split, and from sklearn dot metrics we will import accuracy score. So what is pandas? Pandas are used to convert our dataset into pandas data frame. The second one is the numpy, that is used to build arrays. These numpy arrays are more efficient than regular arrays. The third one is the logistic regression, that is the model that we will be using to train our model. The fourth one is the train test split, that is used to split our documents into two parts. The first one will be the training data and the second one will be the test data. And now we have the fifth part, that is the accuracy score, that is used to determine how accurate our model is. Now we will load the model, loading data to pandas data frame. Credit data is equals to pd dot read csv, because it is a read csv file. csv. Okay, so the name must be something else, so I need to upload it first. Now let me rerun. So it has successfully executed. Now we will be printing number of rows and columns. Printing number of rows and columns. Credit data dot shape. So there are 69,415 rows. That's a huge amount of data. Now we'll print basic info credit data dot info. it's a function. So it will give us what type of data it is, and how many of them are have missing values. As you can see, we have some missing values at some last columns. One values are missing. So what we can do, just let me print separately at how many of them are have missing values. So let's type printing missing values just to make it more presentable. So some of the last column has missing values. So what we can do, we can drop the rows that has missing values. Credit card data is equals to credit data dot drop any. Yeah, now we will again check for missing values to see if our data set has modified or not. Credit data is null, sum. So our data set has modified and it does not has any missing values now. Now let's check the distribution of legal transaction and fraud transaction. TRA transaction. So why I choose class? Because class has the target column, that means the output column. It will decide which transaction is legal and which transaction is a fraud transaction. Now we can see that there is a huge gap. Around 173 transactions are fraud transaction, whereas 69,241 transactions are legal transaction. So it has a lot of imbalance. So what we can do, let me write the text. The data set is highly unbalanced. So what we can do, we can separate the data for the analysis. How can we do it? Let's say legit. Yeah, so we created a variable known as legit. It has all the records whose class is 0. That means which are legit transactions. All are in the legit. And whereas in the fraud, we have all the records which are fraud records whose class is 1. So legit will have around 69,241 records, whereas fraud will have 173 transactions, or you can say rows. Let's print the shape just to recheck. As I said, legit has 69,000 of records and fraud has 173 records. Now we will print statistical measures. Of the data. So I chose only the amount column, and to check its description. So in the amount column, we have a total of 69,241 columns, and the mean is 96. Minimum value is 0. Maximum value is 19,656, and 25% of the data is less than 7.6. 50% of the data is less than 26.5, whereas 75% of the data is less than 88.5. Now, what we can do? Let's compare the values first. Compare the values of both the transaction credit data dot group by class dot mean, just to check if our data set can be separated or not, or our model is able to separate them or not. As we can see, there is a time difference, the difference in v1, there's a difference in v2, v3, and so on. So our model can easily differentiate between them. So it is a separated, the data is separable. Now we will use a technique known as undersampling. It is a very important concept. So what is undersampling? So undersampling is a technique in which we build a database which contains the similar distribution, but the samples are now undersampled. That means the number of instances are reduced just to match with the another another instances of the different class. So what does it mean? Let me explain. So we have 173 fraud transaction. Okay, now we will take random 173 transactions, or first 173 transactions from the ledger transaction, so to make a new data set which will contain what is 173 plus 173, 270, it will around like 240, 240 or 250, sorry 350, or around 350 rows. New data set will contain around 350 records, in which both of the classes will have the equal representation. Okay, that means our in new data set there will be 173 fraud transaction record and 173 legit transaction record. So let's take legit sample of sorry, how many records are there? 173 now, 173. It will take 173 records. Now we'll concatenate those both of them. Legit sample and fraud. What does it say? Okay, I have to add access as well. Access is equal to 0. Okay, now I will print first 5 rows of the new data set. So these are the first 5 rows, and just to tell you, the first 173 rows will be of will have a class 0, that these are the legit, and the last 173 rows will have the fraud transactions. It is still unbalanced, we will fix it later. Now let me print the last 5 rows. Dataset dot tail. So as you can see, the last 5 records has class 1. Now again check for the distribution, just to check our data is differentiable. Class dot mean. So our data is still differentiable. Our model, if trained, can easily differentiate between them. As you can see, there's a huge difference all the values. Now we will print distribution, printing distribution of legal and fraud data, or you can say fraud records. New data set, it will have 173. It's great. Now we will split the data, splitting the data into target and features. X is equals to new data set dot. So X has all the columns except the class, that is a target, and Y contains only the target column. Let's print it, print X and print Y. So X has all the columns except the class, that is the last column, and Y has only the class column. Now we will split the data, splitting the data into training and test data, X train, X test here. So why I use, so there I have 20% of the data is in test and rest of the 80% in training data, and satisfy Y means we are randomly shuffling the all the rows. That is why we use satisfy Y. So the problem we had earlier, that first 173 values are belongs to class 0 and last belongs to 1, it will be solved by the this parameter satisfy Y. So it will shuffle all the rows randomly. Okay, now we can print the shape just to recheck X or shape. Yeah, initially we had 346 rows. After splitting, train has 276 rows and test has 70 rows. Now we will go for model selection, model training. Logistic regression, model.fit, X train, Y train. So we are training our model, so model has trained. Now we will do model evaluation, model evaluation, or you can say accuracy. We will find accuracy score on training data. Okay, why we use training data? First we use this data to train our model, then we will ask the question from the same data set. then we will print the accuracy score, training data accuracy. So our model is 95% accurate. First, we predicted the data using the xtrain which contains all the records except our output. Then we compare both the predictions and our actual output using the accuracy score. Then we printed the accuracy score. We'll same do for the test data. Accuracy score on test data, x test prediction, model dot predict. So our accuracy is coming out to be 90%. That is great. Any accuracy above 70% is considered as nice. That is good. Okay, so we did predicted the on the test data. So that's all for now, and if you have any query regarding any topic, or you can say any line in this project, you can comment down below in the comment section, and don't forget to like and subscribe my channel. Thank you for watching.